We continue from the previous video and look at the 4x4 case where A is given by this matrix and B by this tuple. We're also given that the system has a unique solution. Since the system has a unique solution, not all of U1, V1, W1, and Y1 can be 0. And we assume that U1 is non-zero. You can do similar calculations assuming V1 not equal to 0, W1 not equal to 0, or Y1 not equal to 0. You should get the same conclusions. So what we do is we are going to assume that U1 is non-zero and perform row reduction on the augmented matrix to clear out the entries under U1. And doing that will give you this. Now, if you look at rows 2, 3, and 4, it gives you a system involving only x2, x3, and x4. And there's a square system. And that also has to have a unique solution. So we can apply the result for 3x3 case to the system in red. And we'll be able to write x2 as this. Recall that D3 of this matrix is given by this expression. So what we need to do now is to simplify this as much as possible. And not only that, we want to write it in a way that is analogous to what we had for the 3x3 and 2x2 case. The first thing we need to do is expand both numerator and denominator. And as you can see, it's going to involve a lot of calculations. So I'm not going to do that by hand, and I'm going to use Maple for that. So I've set the values for P1, P2, P3, Q1, Q2, Q3, and R1, R2, R3 to the entries down here. And now I'm going to ask this to evaluate the expression for D3. Alright, so this is what we get, but this doesn't look very useful because we really need to expand this. And we're going to factor out any common factor. And I'm going to call the result D for later use. So this is the result, and you see there's a factor of U1 square here. And there are 24 terms, as you can see, 3 each row. 1, 2, 3, 4, 5, 6, 7, 8. 8 times 3 is 24. Now we need the numerator as well. I need to set P1, Q1, and R1 to the values here. So P1 is going to be this, Q1 is going to be this, and R1 is going to be this. Alright, and now we do the same computations. So this big expression, again with 24 terms and a factor minus U1 square, is the numerator. So to calculate x2, we just take n divided by d, and this is our expression. Now let's take a closer look at this, the denominator here. Each term has exactly one u, one v, one w, and one y. And the indices are always 1, 2, 3, 4, but in some permutation. So each of these terms has exactly one index from each column and one element from each row. Now if you think about that, you should get 4 factorial terms, which is 24, as you have here. And in the numerator, while we have these b's around, but as you can see, the b's replace the second column of the matrix A. The b plays the role of U2, V2, W2, and Y2. So what that means is you can now define D4 to be the following. So this is exactly the denominator, but with the terms rearranged. And using this, you can write x2 as follows. So it will be the D4 of this divided by the D4 of A. And as you can see in the numerator, the matrix is obtained from A by replacing the second column by B1, B2, B3, and B4. And if you work out the details, you will see that x1 is pretty much the same, but the first column will be B1, B2, B3, B4, whereas the rest of the columns are from A. And for x3, you replace the third column of A with B1, B2, B3, B4 and put it up here. And for x4, you replace the fourth column of A with B1, B2, B3, B4 and put it up here. So what we have got for x1, x2, x3, and x4 are analogous to what we have for the 3x3 and the 2x2 cases. Now, we could continue our calculations for 5x5 and 6x6 and so on. But as you can see, doing this for 4x4 is already very tedious. Besides, we need a formula for the general case, so this is not very practical. What we're going to do is, we are going to look at what we have got for D2, D3, and D4, and see if there's a pattern that can be extended. Now, the first thing that you could probably pick out is that each of these terms has exactly one element from each row and each column. And there are exactly 4 factorial terms in D4, 3 factorial terms in D3, and 2 factorial terms in D2. The only thing that is perhaps mysterious is the sign in front of each term. You have minuses and you have pluses. There might be a pattern for the plus and minus, but what is it? And that's the question that we're going to look at in the next video.